All right, everybody, we're in the middle of our vectors chapter, and as I told you in class, we're going to be going over example 4.3 and 4.4, which was the examples that we had just gotten up to in class today before the bell rang. So I just want to make sure, I believe these are still called 4.3 and 4.4. I'm using an older set of notes. I hope the numbers haven't changed, but whatever problems start with these values right here are the ones we're going to be working on. So this one and the following one. Okay, so we have an x component and a y component of a vector. Right? They're not the actual vectors, but they're just the components of the vector, the horizontal and the vertical. So we want to find the full vector A, and we get its magnitude and its direction. Okay, so let's go ahead and just draw this out. X, I'm going to be drawing generally in green, and so we have an x vector of negative 9 meters. Now, why am I drawing it like that? Well, because remember, on the x-axis, that's going to be negative right there. All right, so ax equals negative 9 meters. And our y component is positive 40. Wow, I'm definitely not going to have enough room for this, but that's okay. Positive 40 meters, so this is going to be in the positive y direction. So that is the vector A, the y component equals 40 meters right there. So the question is, what is the resultant, the full vector A from there to there? All right, so A is what we're trying to find. We're trying to find the magnitude of it, so the length of this vector from there to there, and then also the angle theta. Okay, all right, so how do we find the magnitude of a vector? Well, we know that according to Pythagorean's theorem, if we want to solve for the resultant vector right here, we can say that the resultant vector, or the full vector A, equals the square root of ax squared plus ay squared. All right? So let's go ahead and plug those values in right there. And I know I'm going to run out of space real quick here, but that's all right. So the square root of negative 9, the value squared, plus 40 squared. All right, so we take the square root of that. So that gives me a value of A is about 41. All right, or 41 meters. So that's the magnitude of this vector. All right, I'm not gonna box that off quite just yet because we want to get the angle as well. All right, and in fact, I'll just dotted line box that. All right, that's kind of our answer right there. And so let's find our angle. How do we find our angle theta? Well, we take the inverse tangent, right? So if the tangent of theta equals the y over the x value, that means that theta is going to be the inverse tangent of y over x. All right, so let's see. So the inverse tangent, tan negative 1 over what's our y? That's 40. Okay, and our x is negative 9 right there. And let's see what we get. All right, so inverse tangent of 40 over negative 9. Oops. Okay, so you might find that you get an answer that says negative 77 degrees. All right, now what's that negative mean? Well, that means negative 77 degrees in the negative x-axis. All right, so it would be above the negative x-axis. But so we don't get these negative values. What we want to do in the future is when we take the inverse tangent, we want to take the absolute value of each of those, of x and y, just like it's mentioned in our notes, all right? The absolute value of y and the absolute value of x. So just ignore temporarily the fact that one may be negative, all right? Okay, so just doing the absolute value, so just inverse tangent of 40 over 9 will give you a regular 77 degrees, all right? So that is our angle right there. Our theta angle is, I'm really running out of space, equals 77 degrees. Now it's up to you to determine what quadrant it's actually in. Okay, now let's go back over here to our original drawing right here. All right, we have a negative x and we have a positive y. So if this angle theta right here is 77 degrees, it would be 77 degrees what of what? Well, it looks like it's 77 degrees north of west, right? If this direction is west and this is north right here, so it would be 77 degrees north of west. So we need to put that in afterwards because we just don't want to be dealing with negative inverse tangent values. Do the absolute value here, and then when you're finished, go back to your original drawing or sketch and figure out, okay, what quadrant is that actually going to be in? So let's return to our actual answer right here. So this is our direction answer. This right here is our magnitude answer. And so we're just going to write it all out. So since I just about ran out of space, in fact, let me see if I can pinch this down a little bit. Yeah, all right, well that works too. Do the whole page. We're going to say that our answer for A is going to be 41 meters at 77 degrees north of west. That is going to be our final answer for the first part of the problem right there. All right. I wonder what happened if I did this. It just makes it big again. You know what? I'll just put that on top so it's kind of out of the way. That's the answer to our first part. I think we can use less space with our second part right here. But I probably should have locked that background down. All right. So let's do part two. So we're solving for, well, it's not really part two, but it's a different vector. We're finding vector b right now. Okay. So the x component of b is -8. -8 meters, so bx equals -8 meters. And the y component, once again, is positive, all right? So I'm going to make that blue, a little more proportioned this time. So by, that's a y, not a 4 right there, equals 15 meters, and we want to find the resultant vector of that. All right, again, we start at where the origin would be, right here, and go right up just like that. So our vector b is what we're solving for. We want its magnitude and we want its direction, what angle above what axis. Okay, so let's find the I just lost my train of thought. The magnitude. Sorry. Okay, so our magnitude b, our full magnitude of the full vector, is going to be the square root of bx squared plus by squared. All right. In our case, that's going to be -8 squared. Do the square root of that. Plus, what is that? 15 squared. Okay, and that's going to give us an answer of 17. 8, 15, and 17. I think I recall that being a full right triangle. All right, 17 meters. So that is just our magnitude, so you might want to dotted line box that. All right, let's see if I can save a little space now at the bottom to put our final answer. Now let's solve for our angle theta. Okay, what is this angle right here? So theta is going to be the inverse tangent of what over what. Now remember, this is going to be absolute values, so it's the inverse tangent of your y over your x, right? So theta equals inverse tangent of, what's our y? That's 15. Oh, I don't really need to put the meters in there. Just do 15 over 8. Okay, remember, this is absolute value, and we're going to determine the quadrant a little bit later on. So theta is going to be, it's going to be 61.99 degrees. So let's just round that up to 62 degrees. Do a little dotted line box right there. Now let's ask ourselves, what quadrant is this going to be in? All right. So we were in the negative x, but we're in the positive y. So this is going to be some angle that's above the negative x-axis, very much like the previous one. Okay. So the 62 degrees is going to be 62 degrees above the negative x-axis, or you might say north of west. okay, north of west. So let's just put it all together. We have our final vector right here. So vector B is going to be 17 meters, it's a 7, not a 2, at 62 degrees north of west. Just like that. That's our magnitude right here, and that's our direction. Got our magnitude and got our direction. So I got a little bit sloppy right there, but we're going to do the next example in the next video. I'll see you then.